motherboards. So we talked about the cases. Now we're going to talk about the motherboard, and we're going to keep building pieces on until we get a full computer. So what is a motherboard? The motherboard is really the foundation of our computer. It's what everything else plugs into, okay? The motherboard, I like to think of it like a city block. And the bus, the little electrical wires that are going throughout it, are the streets. And all the different components are the buildings, right? So if I look here, I have a processor. I have a north bridge. I have my output and input ports. I've got some expansion slots. And I've got some memory slots here. All of these things connect together through that motherboard. Without the motherboard, they have no way of talking to each other. The design of the motherboard is called the form factor. We talked about that in the last lesson. We talked about like the ATX form factor. This board we can see is a mini ATX board. And the way we can see that is because if it was a full ATX board, we'd have a whole lot more than 4 expansion slots, right? But we can see there's a rear port cluster. We can see that the expansion slots are parallel to the shorter side of the board. And so this makes it a mini ATX board for us, right? Or a micro ATX, excuse me, one of the two. This one probably looks more like a micro based on the size. The motherboards are the central meeting point of all the technologies in the computer. Everything plugs in through the motherboard and everything has to go through it. So, for your exam, they might give you something that looks like this. And they're going to give you A through O or 1 through 15. And they're going to say, label. And you'll move hockey pucks around and make sure you label things. So you have to be able to look and go, number 1, those are PCI slots. Number 2, those are PCIe X1 slots. And I know this means absolutely nothing to you yet, but we're going to cover each of these things in detail, I promise. Number 3 is a PCIe X16 slot, right? Number 4 is my rear input-output cluster. Number 5 is my processor. Number 6 is the power that goes to the processor. Number 7, we've got our RAM slot, which is memory. Number 8, we've got our main board power connector. That's that big white thing there at the bottom. Number 9, this is where our connectors for our power and reset buttons and activity lights go. Number 10 is a K-stand port, this little white piece next to the 10. Number 11, we have our floppy disk connector. That's that green port right there. And then number 12, those yellow ports off to the side are USB header connections. And we'll go ahead and we'll talk about all these in depth as we go through, right? But you'll get an image that looks like this or something similar, and it'll say, label these ports. Later this afternoon, we pull apart the computer. We're going to look at these and we'll talk about each of the components as we go through them, okay? So integrated I/O ports, that rear port cluster we were talking about, right? There's a standard 3 different places you're going to find integrated ports. One is the rear port cluster, which all the motherboards have at this point, all the ATX-based motherboards. We also have some front ports that are routed by headers to the case. So if you look at the front of your PC by your feet, you'll see there's some USB ports, a microphone in, and a headphone port, right? Those actually have cables that are going to the motherboard, which are called headers. We also have rear port cases. Often they'll have a header as well. For instance, here at the bottom, you can see this 4-port USB, and these cables that come off, they'll plug into the motherboard. That's called a header, the USB header. Headers are most commonly used for additional USB ports, sometimes used for things like FireWire as well, but really USB is the main thing we use those for. So, integrated I/O ports. The traditional ones we've had in the past is A and B. We have our PS2 mice and keyboard connections. C, you have USB. Those are some older 2.0 style USB. We also can have our Ethernet. Like number J, there is Ethernet connection. Could be a 10100 or a 10100-1000. We'll talk about those in networking a lot more. We can have stereo or surround sound, either 5.1 or 7.1 that can be integrated. So on the top image, we have regular stereo connection, just this H jack. If we look at this middle picture, we actually have some newer stuff like the SPDIF connector, which is Sony Philips digital interface format. We'll talk about those more later as well. Or below it is the optical version. The one at top, the orange one, is the coaxial version. The red eSATA port here in the middle, that is for external hard drives. It's called eSATA. It's actually a very fast connector. We also have USB. This one actually has Bluetooth embedded as well. You can see the Bluetooth symbol. This is a FireWire connector. These SS is super speed USB, which is USB 3.0. And then we also have things like integrated video. So this E1 up here is VGA. It's a video graphics adapters at older format. And you might have some newer formats like HDMI or DVI-D. And then some older stuff, legacy stuff, will be things like serial and parallel ports. So parallel port is what we have listed there, K in pink. That's a parallel port was used for printers in the old days. Nowadays, what do we use? USB, right? Serial port is D. It's a 9-pin adapt. Actually, I'm sorry, that's a gain port. That's actually got 15 pins. So D up there is actually a gain port, which is an old 15-port way of hooking up a joystick. Nowadays, we use USB, right? So a lot of this stuff has been used over and over, and we've changed it out. In the bottom graphic, you can see I do have a serial port shown, which is a 9-pin adapter. And again, that's been replaced by USB at this point. So most of that stuff you're not going to find on newer machines. It's older stuff, but we still got to understand it. And we'll go through each of those things in depth. We'll talk about USB in depth and FireWire in depth and all different graphic formats in depth to make sure you guys understand what they are and what they do and what their capabilities are. So the front panel connectors, the other things that we have to attach are things like our lights and our power buttons. If you don't connect the power button when you build your computer and you keep hitting the on button, nothing's going to happen. I've seen that before many times. Why can't this thing turn on? Because the power button's not connected. All the connectivity for those type of things, case speakers, reset buttons, activity lights, power buttons, hard drive lights are done through cables, as you can see in the upper right hand corner here. And they attach these little pinouts on the board. In this case, we have the power light, we have the reset switch, the power switch, and the hard drive light, and those will be routed to the front of the case. These are usually grouped on the front edge of the motherboard. As you can see here, they are very small and difficult to handle. You can see in the bottom picture how small they are in comparison to this guy's hand, right? Usually they unplug very easily while you're doing other work. So you go in to replace a hard drive and you happen to unplug one of these and now the computer won't turn on. It's not that you broke something, it's just that you probably unplugged the power switch. Something like that. So it's one of these things that I always check before I put the cover back on is, are these things still connected? Right? It's easy, quick check. The front panel connectors, to install them, you need to ensure that you check your motherboard documentation because every motherboard does them differently. There's no standard way for this. Usually they'll be labeled on the motherboard themselves. But for instance, if you look in your manual, you'll see a little diagram like this. PLED stands for power, LED being the light. The speaker, this is a 4-pin speaker connectant that'll go to the case speaker. That's what you turn on the computer and go beep. That's the speaker I'm talking about, not the one you actually listen to music on. The reset button, the power switch, and the IDE LED is another name for the hard drive LED. The reason why it's called IDE LED is that's the old integrated drive interface that we used to use. So it's just kind of a legacy term that's carried over. So if you see IDE, it's also means hard drives. Audio connectors. On the front of your PC is usually there can be a headphone jack and a microphone jack. Those are also run based on these header cables, and they'll plug into the motherboard. If you have a CD drive or a DVD drive, there's going to be a cable that will actually connect called the CD in, and you'll run that from the drive to the motherboard. If you want to have a header cable like this SPDIF header that we have at the bottom here, it's going to plug into the SPDIF plug port on the motherboard as well. And that gives you optical, which means digital high quality audio output. So on the motherboards, we also have the fan connectors. So we talked about the fact that we need to cool these motherboards. We need to cool our processors and all the heat that is generated by the computer. To do that, we use case fans. Most cases will have at least one case fan. Some of them have 2 and 3 case fans now. And so most of the motherboards will have multiple case fan connectors around the board. I've circled them all in yellow here so you can see them. They will provide power to the fans through the motherboard. Newer boards can also give you health and status through your BIOS of them. So they'll tell you how fast those fans are spinning. So when we play with our machines later, we'll actually turn it on and you'll see that the fans are spinning at like 3,600 RPM, rotations per minute. So it's like 60 times per second, right? Let's tell you this, the case fan, it'll tell you how hot the motherboard is. So they'll say, oh, this temperature is 39 Celsius. If it gets to 42, we're going to turn the fans faster. If it gets too cold, we'll turn the fans slower, and it'll adjust based on that. And also tell you the power going to the fans to make sure that the fans are getting the adequate amount of power. The CPU case fan, the CPU fan will actually sit right on top of the processor, and it has 4 pins instead of 3 pins for your case fans. The 4th pin is actually speed control, because as it is detecting the temperature on top of the processor, it will spin faster or slower to get that temperature hotter or colder as needed, because you don't want the processor to get overheated and burn out. That's a very expensive mistake. So we use that speed control for that. Yes. So if it gets too cold, they're designed to be at certain operating temperatures. If they're too cold, they won't operate properly. The electrons don't flow at the right speed, and that could slow down the processor and do, it basically slows down your system. Yeah. Much rather if you buy a new computer, it'll say, operate this between this temperature and this temperature, right? Usually it's between like 50 and 100 degrees. So if you're in the desert, it's 140 degrees. It's going to degrade your system performance because it could overheat. If you're in the Arctic and it's 20 degrees and you're outside in the snow, you can also have problems for performance as well. Jumpers and jumper blocks. You guys may or may not have ever seen jumpers or jumper blocks. I'll show you some in this class as well. But basically what a jumper is, it's a little plastic piece that has a metal in between it. And you can see one here on this drive, or right here on this CMOS clearing station. And what you actually do is it's making an electrical connection between these 2 pins. And so in this case, if I wanted to clear the CMOS, I would pick up this blue jumper and put it on these 2 pins. By doing that, I would leave it there for 5 or 10 seconds. Whatever my motherboard tells me, it's going to clear the settings of that memory. And then I can put it that. On this drive, for instance, it tells me which one is master and which one is slave. And we'll talk about that when we get to storage. But essentially in the older days, you could have two drives on one cable. Or if you had 2 people on one cable, like in this class, we have 2 NICs, right? And so if I said, hey, Nick, you both are going to answer up. So I would say, okay, when I'm talking to Nick, the first time I say Nick, I'm talking to Nick in the front row. If I say Nick, then I'm talking to Nick in the back row. That's the master-slave relationship. Master is first, slave is second. It just dictates based on the cable which one's going to answer up first. And so we'll talk about that more in storage, but that's the idea. And we use a jumper to do that. And we can just move it from the master position to the slave position or the cable select position. The jumper block is that small plastic piece with the metal in it. When the jumper is placed over the pins, it makes that electrical connection, and we can do this for motherboard settings or drive configurations. And again, the CMOS settings, which we'll talk about when we get into BIOS, can be cleared by moving that jumper to the clear setting. And here's a simple question for you guys. A technician is installing hard drives into a computer and needs to set jumpers on the drives to master and slave. Which of the following drives is the technician installing? So we haven't really talked about this yet, but what it is it's going to be your EIDE drive, and those are the kind that use a jumper. Now, once we get into drives and storage, this is going to be a really easy question for you, because you're going to learn, as I'm sure you guys have used before, USB, 1 drive, 1 cable, right? You guys all have external hard drives, 1 drive, 1 cable, so there's no jumpers. SATA is the same way. It's 1 drive to 1 cable, so there's no jumpers. And then SCSI uses actual dip switches and rotary switches. We'll talk about that. It's an older technology as well. The EIDE is what we're talking about here. And I'm just bringing this up to make the point of we're talking about jumpers. That's kind of the question they'll see with jumpers. The big thing for motherboards, you got to be able to identify that if pieces of parts on that motherboards, the diagram like I showed you, being able to go, this is this piece, this is this piece, that will come up. That has typically been one of those simulation performance-based questions on the A+ test. That comes up quite often.